The last section of 12.1 is going to be on how to present data in terms of the graphs. And a histogram and frequency polygons are two ways that graphs can be used to represent the frequency table that we were discussing earlier. So this is the same data set that we had earlier when we used the frequency table, looking back where we had we tallied the ages from when they were 10, we had a frequency of 1 and 11, 2, etc. And so if you notice in the histogram, the bar graph will touch the value that they have for the frequency. And you also, to construct that histogram, remember the y-axis or your vertical axis is going to be your frequency, where your horizontal axis is going to indicate, then in this case would be the years or the data values. The next one is a to construct it, again, you're just going to use bars to indicate it. It will also be divided equally between, for instance, like in 10 and 11, you'll find the halfway points between, and then your bar graph will include all of that rectangle that it includes. A frequency polygon is used by forming a line, and you use that line in the midpoint of your bar graph. And so in other words, at 10 you're going to see a point. At 11 you'll see 11 when there's a frequency of 2, you'll also see a point. And then a line then is drawn then to connect those. The dots will also indicate the class frequencies when they're connected. You have to be a little careful when you're representing visual displays for data, because a lot of times it can be deceptive. And depending on where you put your y-axis in terms of the intervals in between, you can see that this is a data, the three graphs represent the same data points. But if you notice, it looks a lot more dramatic when we see it. There looks like a rapid increase, but then you have to look at the percentages, and you're only increasing your percentage by 0.4 each time. Where on the second one, you're increasing it by each percentage. And so again, this one doesn't look like as dramatic as this graph, where your intervals are a lot different. You have to watch for a couple of things. So look over your notes. Remember the things to watch for. Is there a title that explains it being displayed? And so, again, going back to our example we had earlier, this is going to be the percentage of people in the United States living below the poverty level from 2001 through 2005. Are the numbers lined up with tick marks on the vertical axis? In other words, you need to have this piece of data. And they indicate the scale. And so different scales between these two different graphs, but it also changes the look. Are there too many designs or cosmetic effects can draw attention from or distort the data? And I'm going to give you an example on the next page. Has the wrong impression been created about how the data are changing because of equally spaced intervals and not used on the horizontal axis? And so again, when you look at your horizontal axis, you do want to make sure that the intervals are the same. And notice that we have a break in that, and that's how you represent. If not usually this is the point, the origin is 0, 0, and so if you're going to start at a point that the next point would not be 1, then you would also indicate there's a break. Are the bar scales scaled proportionally in terms of the data they represent? And is there a source that indicates where the data, the display came from? And so again, these are things that will also help us interpret the data that we're given in the graphs that they represent. Here's an example of a misleading visual display, and some of the problems that you have on this one when you're looking at the number of square feet in an average U.S. home family. If you notice on the bar, we go from 1980 to 90, and then they also then jump from 1990 to 2010, and so we're not consistent on your horizontal axis on the places where you're breaking. And also the fact that they've added the shadow and made the house look a lot larger, it doesn't necessarily mean that it's representing the graph in the way it's supposed to. So again, in this case, the data indicated it was greater increase from the area from 1980 to 1990, and the fact that that's in proportion. It's not the same portion. So when you have a scale, it's hard for us to actually make those have a data point, because it's hard to make sure that they are in uniform size. So keep that in mind when you're making your graphs and adding those data pieces to your set.